Hello, and welcome to a question answer by www.free-academy.com. When we post lectures to our website, students have the opportunity to submit questions to us, and we'll answer them if they're good questions, give video lectures, just as much academic support as we can possibly provide. And on our trigonometric derivatives lecture, a student wanted to know why the derivative of sine, cosine, tangent equals their counterparts. The crux of the issue comes from the rigorous definition of the derivative, which I'm not going to go through all of them because I don't want to spoon feed calculus, but I want to be very illustrative on the matter. So I'm going to do the derivative of sine, and if you go through this process, you can find for all the rest of them, you can find their derivatives. You probably don't need to know this, but hey, if you do, great. All right, so let's get started. We're going to have to expand this out so that we can eliminate h. And you know the process for solving the rigorous definition of derivative. And if you are unfamiliar for this, we have a lecture that you can check out and it'll explain it for you. Now first, I'm going to start by applying the addition formula for sine, which allows me to expand the line like this. Oh, just so you know, I'm going to leave this part out until the end, just to save time in writing. But that technically does follow on every single line. It's a little ugly there. Rewrite that. We got from there to there by the additive rule of sine. Can't spell today, apparently. Really can't spell today. Alright, so once we get from there, now we're going to factor stuff out. Before I'm going to do this, I'm going to rewrite this by dividing h into every term. So we'll have sine of x cosine of h over h plus, actually, minus sine of x, you'll see why I do that, over h plus cosine of x sine of h over h. Alright, now what I'm going to do is I'm going to take this term right here and I'm going to factor a sine out of it. So this will give me sine of x, and in brackets cosine h minus 1 over h and now I'm going to factor this cosine out of this term, cosine of x brackets sine of h over h. Alright, now I got this into a position where I can apply the limits. The limit as h goes to 0. Sorry about that little pause there, I just wanted to double check something. Okay, now we're in a position where we can apply the limit to this broad term here. Sine of x and cosine of x, they have no h in the term, so nothing's going to happen when we apply the limit. So we can pull those right out. Sine of x, limit as h goes to 0 of cosine of h minus 1 over h plus cosine of x, limit as h goes to 0 of sine of h over h. Actually, let me check something again really quick. Alright, now, there are some formulas that I haven't shown in this class, but you could look them up for these limits here. This particularly is a very, very commonly known limit. The sine of x over x as x goes to 0. That equals 1. And this one equals 0. I don't have the explanations handy for them. I'll probably put up a lecture explaining why these are the case. It's probably a pretty important thing to know. But as of right now, you can look this up. You can find this for yourself. But let me make some room up here again. We're going to take this line, shoot it up there. So this will give the sine of x 0 plus the cosine of x times 1. So the derivative of sine of x equals cosine of x by using the rigorous definition of the derivative and looking up a few different properties. Hope this was helpful. Happy to answer your question. Have a nice day from www.freeacademy.com.